Bearcats. We are going to do 4.5 day 2. We are continuing with graphs of sine, and cosine. Alright, let's review a little bit about our basic parent functions. Let's talk about our sine graph first. Remember that we have our basic points for our key values along our unit circle. So we start at 0, at pi over 2, at pi, at 3 pi over 2, at 2 pi, and so on. And on the other way, if we went the negative, or we went in a negative rotation, which would be a clockwise rotation, we would end up with negative pi over 2 and negative pi, and it would continue. Remember that sine starts at the axis. We'll make this 1, this negative 1, and we're going to build our little highway. Make it easy to graph. Build our little highway down here. Kind of make it easy to, easy to graph. Alright, and sine starts at the axis. So, our parent function at pi over 2, the sine value is 0. At pi, it is, it's a 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's back to 0. If we went the opposite direction, at negative pi over 2, we would be at negative 1. And at negative pi, we'd be back at 0. So, our sine graph in one period looks like this. Of course, it continues both directions, so we could start extending that period and start into another period and go this way, and it would continue. So the domain of a parent sine function is negative to positive infinity. The range of a parent sine function is negative 1 to positive 1. And the period is 2 pi. The amplitude is 1. And that's for a parent function. And by now, hopefully you're getting the hang of that. Let's go ahead and do the parent function of cosine. Also, if you need to pause and make yourself notes, go ahead and do that. I'll be right here waiting for you. Alright, so our cosine parent function, again, we're doing this off the unit circle. We're going to go ahead and build our graph and our little highway. So again, this is our axis, and our key values again are at 0, pi over 2, pi, 3 pi over 2, 2 pi, and if we went in a negative direction, negative pi over 2, and negative pi, and so on. Again, we'll make this from 1 and then negative 1, and we'll build our highway. I guess if this were a real highway, these would be really curvy drivers. They would not be very stable drivers. They'd probably be stopped by the police. Alright, anyway. Alright, so back to our graph. Remember that cosine always starts at the amplitude. And if it's positive, then it's going to start at the top of the amplitude, which would be up here at the top. At pi over 2, be at 0. At pi, bottom of the amplitude. Back to 0, top of the amplitude. Again, 2 pi is one rotation of our graph, or one cycle of our graph, and our cosine graph looks something like this in one cycle. Looks a lot like the sine graph, just shifted over. If we shift this over pi over 2 to the left, it would look just like our sine graph. All right, and it would continue, and it would go down here and then back down. And it would continue the whole cycle again. So it would continue both directions, but one period would be 2 pi. Again, just as in the sine graph, the domain is negative to positive infinity. The range, negative 1 to positive 1. The period, which is like the cycle of the graph, is how that curve from here to here, that curve takes in one rotation of the circle, and that is one cycle of our graph, and that occurs in a parent cosine graph in a distance of 2 pi. and our amplitude again is 1. All right, so just a recap again, the key things from our equation. Remember that we've got our vertical shift. I guess we could actually write that equation again. The more times you write these equations, the better off you're going to be in terms of memorizing them. So you might want to stop right now. Just pause the video for a minute and see if you can from memory write your equation. If you can't, then unpause it and go on. All right, hopefully you wrote this equation down. This would be the equation that from the basic forms of with all of our transformations for sine and cosine. Don't forget that the order in which I would do my transformations, and we're going to practice that here in a minute in some examples, would be I would do D first. D, remember, is our vertical shift. Which sets your axis, middle of your highway. And then I would do my amplitude, which is your absolute value of A. And this sets your parameters, your amplitude. Then I would worry about my period and my phase shift. And those you kind of have to think of together. I think you should probably figure out your period first. So that's your 2 pi over B. That's your period. That's the distance in which the graph has one cycle. So that distance could be stretched or compressed. And then last you would want to know your phase shift. And your phase shift is the C over B. Sorry. Which is really your horizontal shift, left to right. Your period, which is really your horizontal stretch or compress. And again, we've talked about that. We did some classwork yesterday. You're probably pretty good, but this is just a review for you. Let's work on 5 examples really quickly, and that should set you, give you some examples online that you can go back and refer to. You have some examples in your textbook. We did some in class from the workbook, and then of course tomorrow in class you're going to have a packet, a worksheet packet with a few more difficult transformations of sine and cosine, and then we'll move right on into the cosecant, secant, tan, and cotan graphs. Alright, so let's go ahead and take these examples. Alright, here's your first example, y equals sine x plus 2. Okay, we're going to take a little look at this and see if there's anything we need to analyze. I only see one transformation in this parent function, and that would be positive 2, and that's at the end of our graph. It is not affecting x, it's not in parentheses or anything, so that would be a vertical shift of up 2, which means our axis would change. Our axis would change. So like 2 is, this is the D value, which affects our axis. So I would make myself a few notes to the side of my paper. I would make myself that my axis is now y equals 2. I would go on and talk about the rest of my graph. My amplitude did not change, so my amplitude is 1. My period did not change, so it is 2 pi. And I had no left and right shift. My domain would be negative to positive infinity. I know that because it's a sine graph. And my range. Now, my range, if my axis has changed, my range is going to change because that changes my y values. So before I write in my range, I'm going to go ahead and do my graph. So let's go ahead and sketch in our graph. Alright, so we're going to have a new axis. Let's make our new axis in a different color. That will help us. Oops. All right, so our new axis has shifted up 2. So we're going to count up 1, 2 right here. And so I'm just going to kind of draw my new axis here. I'd really like to draw that in with a really bold marker. I don't know how I can't get that bold marker right now. So I'll kind of go over it a few times. But this is my new axis. Really important. You can use a, sometimes I use a highlighter to highlight my new axis. Let's see if we've got that up. You know, this little thing didn't want to stay. Alright, let's see if I can highlight that. We'll highlight in yellow. So there's our new axis. Just make sure that we realize that we don't get it confused with our old axis. And I think that's really, really, really important. Okay, so back to our graph. Our amplitude is 1, but it's 1 from the new axis. Since this is our axis, then our amplitude of being 1 would be here and here. And that's where our little highway would be built. So I'm going to dot in my new highway. Feel free to use any kind of color you want. And then I'm going to mark my key values on my new axis. So even if they were marked on my grid down here, I would go up and mark them on my new axis. And I know this is at pi, and I know this is 2 pi, and you know that's pi over 2 and 3 pi over 2. Alright, so we have that, and of course then this would be your negative and your negative pi. Alright, so sine we know starts at the axis. We now have, nothing else has changed. We have a period of 2 pi, so we're going to be from 0 to 2 pi is our whole cycle. And we start at the axis, and our axis now is here. So at the axis, then we would go to the top of the amplitude, back to the axis, bottom of the amplitude, back to the axis. So one cycle would look like this. One cycle would look like this. And that's with a an axis shift or a vertical shift in our graph. Alright, let's take a look at the next example. Alright, when we take a look at this one, we see that we have a 3 in the front. If we think of old traditional transformations, that's not affecting x, that's affecting y, and that would be a stretch of 3. And in cosine and sine graphs, I want you to think of that as a amplitude change of 3. The amplitude, the wave was going to go all the way up to 3 and all the way down 3. So let's go ahead and build our graph and our highway. So in this case, here's what happens. Our axis has not changed, so it's still y equals 0. Our amplitude has changed, it's going to be 3. Our period, in this particular case, is not changed, it's still going to be 2 pi. And it doesn't seem to we have a reflection or any kind of vertical shifts left or right. So let's go ahead. Since our axis is still going to remain this, we're going to build our highway. Our key values in our axis, of course, are still pi over 2, pi, 3 pi over 2, 2 pi, etc. Our amplitude now is 3. So from the axis, we have to count 1, 2, 3. And we have to count down 1, 2, 1, 2, 3. So there's where our new highway is going to be. So let's go ahead and build our new highway. And once again, remembering that sine starts at the axis. Cosine starts at the amplitude. No reflection, so at our first key value, we would go up to the top of the amplitude, back to the axis, to the bottom of the amplitude, back to the axis. And our graph will look something like this. Oops. So our graph got stretched vertically, and that's what the 3 in the front will do for us. All right, let's look at example 3. Alright, this time our graph, something is happening with our x value, and it's minus pi over 2. So just like in transformations before, we're going to go to the right. We're going to go in the direction that you wouldn't really expect looking at this. We're going to move to the right by a distance of pi over 2. So we're going to have a horizontal shift. It's called a phase shift. We're going to have a phase shift. So once again, our axis will be the same. It's going to be y equals 0. Our amplitude is going to stay the same. It's 1. Our period hasn't changed. It's still 2 pi. So the distance is a distance of 2 pi. It just may not, it may be shifted over, so the graph may not end at 2 pi. If you do one cycle, it may end before that or after that based on our shift. And then we have a phase shift of right, a distance of pi over 2. All right, let's build our graph and see how we do this time. Our axis has stayed the same, so we have pi over 2, pi, of course, with 0 there, 3 pi over 2, 2 pi, and because we're going to move to the right one, let's go ahead and add another hash mark and label it. So if this is 2 pi, and we're talking about halves, that's really 4 over 2. Okay, we've got to go back and think of our reference angles. This is really 4 over 2. That would make this 5 pi over 2. And that's going to be important to us. Let's go ahead and build our highway. Our amplitude is 1. We're going to say this is 1 and this is -1. And I'll just dash our lines in to build our highway. Alright, now we've got our highway built. Okay, traditionally, and what you've done in the past, if you started right here, because sine starts at the axis. Sine does start at the axis, but our sine graph in this case has shifted to the, to the right pi over 2. So we're going to take that point and move it to the right pi over 2, and that's our beginning point for this graph. Then at the next key value, which is at pi, we're going to go to the top of the amplitude. Back to the axis, bottom of the amplitude, back to the axis. And we end at 5 pi over 2 because the distance between pi over 2 and 5 pi over 2 would be 4 pi over 2, which is 2 pi, which is our period. So this graph will look like this. Notice if we move backwards and we restricted this, it would almost look like a cosine graph as well. Okay, that's example 3. Let's move on. We have 2 more. Alright, this time we have 2 times x. So something is happening with x, it's multiplied, so we're going to know that that is a stretch or compression. If you remember from our previous transformations that we've been doing, remember anything happening with x happens opposite of what you would expect. So instead of doubling the x values or the length of our graph or stretching our graph, in this case it'll actually compress our graph. There's kind of a special way with sine and cosine, our trig graphs, that we really write that. So let's go ahead and go back to our basic stuff. Our axis has not changed in this case. Nothing is moving up or down, so our axis remains at y equals 0. Our amplitude, there is nothing in front of sine, so our amplitude, there's been no vertical stretch, so our amplitude is 1. Our period is going to change this time. It is going to change this time. Now, our graph has not shifted, so there's no phase shift. But our period has changed. It is no longer 2 pi. If you go back and refer to your notes, to find the new period, we take 2 pi and divide by b. And when we do, we just get pi. So the entire cycle of the graph has to occur between 0 and pi. Let's take a look at how we would make that happen on our graph, at least the easiest way we can make that happen on our graph. I'm going to kind of exaggerate this graph a little bit just to give us a little bit more room. So this is at 0. I'm going to kind of make this big. This is pi over 2. This is pi. And our entire graph has to have between 0 and pi. But if you remember in the past, between 0 and 2 pi, there were 4 dots in the middle. There were 2 more critical values. And we're going to pick those values in a second. Let's go ahead and do our amplitude. I'll say this is 1. I'll say this is -1. So I'm going to build in my highway. All right. And sine does start at the axis. So our sine graph will start right here at 0. But we want the whole cycle, the up and the down, the top of the amplitude and the bottom of the amplitude, all to occur between 0 and pi. So we need to pick a value halfway in between 0 and pi over 2. Think about your unit circle. If you're at 0 and you go to pi over 2, halfway in between was 45 degrees or pi over 4. So if this is 1 over 4, this is 2 over 4, and halfway in between here would be 3 pi over 4. And so we have to label those values, and it's really important that you can identify the numbers and label. So we're back starting at the axis. Our next key value would be to the top of the amplitude, back to the axis, bottom of the amplitude, back to the axis. And this graph is just like the parent function, except that it has been compressed into a distance of pi instead of 2 pi. So this is a compression of the sine graph, the basic sine graph. All right, last example. We have a couple of things going on, and we want to talk about how to handle this situation. So this is the last example for the evening, and then we'll have worksheets tomorrow. All right, in this example, notice that the 2x, there's nothing factored out. Like in the equation we've been using, the 2 would be factored out, and we're about to do that. Right now, 2 is our b value, and pi over 3 is our c value. And that's a little hard to read in here, but that's how that works. So if we rewrite, oops, no. Rewrite this equation, we get y equals sine, and it's going to be a bracket, and we're going to factor out the 2. We're going to have an x, and remember what we do, it's c over b. So it'll be pi over 3 divided by 2, or pi over 3 times 1/2. You can think of it that way. And if you do think of it that way, that's actually easier, and you're going to have 1/6, or pi over 6, sorry, so we're going to minus pi over 6. And there's no d, there's no up and down shift. All right, let's identify a few key things, and then let's see if we can graph this graph. Okay, this is kind of extensive in finding our values, so you're going to have to pay a lot of attention. You may need to watch this once, then go back, take a few notes, freeze it, take a few more notes, and then you might want to just watch this example one more time. It's not that it's so difficult, it's just a lot of converting our fractions to get a common denominator so that we can pick our correct key values. All right, so let's see what's happening here. The axis has not moved. So our axis will remain at y equals 0. Our amplitude has not changed. Our amplitude is still going to be 1. Now, here's a few things that have changed. Our period has changed. Remember we talked earlier about that in this case the period would be 2 pi over b, which is 2. So pi. So the cycle will have to occur in a distance of pi. And now we also have a phase shift. So the graph is going to move to the right a distance of pi over 6. Well, if it was supposed to end at pi, it's going to end at pi plus pi over 6. So that's kind of a key thing. So let's take a look at what that, just kind of knowing that, let's think about what's happening here. So our axis stays 0, our amplitude stays 1. Our period is only going to be a distance of pi. A distance of pi. I'm going to go ahead and put our original key values on here. There's pi over 2. There's pi. 3 pi over 2. 2 pi. Okay, those were our original values. Our period now switches and is going to start at 0. Well, it's actually not going to start at 0. It would have started from 0 to pi. So the original distance of the parent function, or for this function, the period to be from 0 to pi. But we're going to have to shift over pi over 6. So when we add pi over 6 here, then we're going to have pi plus pi over 6. Well, 6 would be 6 over 6 plus 1 more would make this 7 pi over 6. That's where it's going to end. And we're going to shift from 0 a distance of pi over 6. So it's going to be right here, pi over 6. What else can we do? Pi over 2. So we need all our critical values. So we know we're going to start right here. And we know we're going to end right here. So let's figure out what's halfway between pi and pi over 6 and 7 pi over 6. That would be 8 pi over 6. If I went halfway in between, that would be 8 pi over 6, which would reduce to 4 pi over 3. So halfway in between, I'm just going to put a dot there, you would be at 4 pi over 3. Now we need a halfway between pi over 6 and 4 pi over 3. Well, if I convert them both to 6, this would be 8 pi over 6 and 1 pi over 6. So this would be pi over 6 plus, this would be times 2, so 8 pi over 6, which would be 9 pi over 6, both divisible by 3, which would be 3 pi over 2. So 3 pi over 2. I think I'm going to stop right here and erase this. Sorry. I think what I'm going to do is, we knew that we shifted from 0 over pi over 6. We also know we're going to shift pi over 2 plus pi over 6. Let's do that. So if I change this, this would be 3 pi over 2 plus pi over 6, which would put me 4 pi over 2. Oops. Four pi over 6, sorry. Which would put me 2 pi over 3. So if I'm at that, halfway in between here would be 2 pi over 3. And then we're going to have to be halfway in between 4 pi over 3 and 7 pi over 6. So 4 pi over 3 plus 7 pi over 6. Alright, well, when we convert this, that's going to be 8 pi over 6 plus 7 pi over 6, which is 15 pi over 6. That's going to be 5 pi over 2. You know what? I don't really like, I'm not sure I like the way I approach this problem. I'm going to start over. Okay, example 5. We have sine equals 2x minus pi over 3. We need to rewrite, factoring out our 2. So we get y equals sine, bracket 2, x minus, and then there would be, this is actually your b value, and this is actually your c value, and it would be c divided by b, or c times 1 over b, which would be 1 over 2. 3 times 2 is 6, so it would be minus pi over 6. and those are the changes. So in this case, we have our axis. Well, our axis hasn't changed, no vertical shifts, so our axis is still at y equals 0. Our amplitude, there is no vertical stretch or compression, so it's still 1. Now, both the phase shift and the period has changed. So the period is now going to occur between, well, it's 2 pi over 2, or pi. So between 0 and 2 pi, or a distance of pi. And then we have a phase shift of right pi over 6. Let's draw our graph, and then we're going to create a table to help us find what critical values we need. So here's our axis, here's 1, here's -1, this is our highway. And let's take a look. Let's do a little chart here. Let's look at what our original points are. We're originally going to go from 0, I'm going to kind of exaggerate this, to pi. So halfway in would be pi over 4. And halfway, be pi over 2, sorry. Halfway between 0 and pi over 2 would be pi over 4, and halfway between pi over 2 and pi would be 3 pi over 4. Now those are the original points. We're going to move each of those points. We're going to add pi over 6 to each of those points. Let's create the little chart. So the original points are at 0, pi over 4, pi over 2, 3 pi over 4, and pi. And what we want to do, we have a phase shift of pi over 6. What we want to do first is we want to create a common denominator for all of these. So we're going to change all the denominators to 12. So if we change this to 12 here, it's going to be 2 pi over 12. 0 is still just going to be 0, or you could even think of it as 0 pi over 12. For 4, or pi over 4, it's going to be 3 pi over 12. For pi over 2, it would be 6 pi over 12. For 3 pi over 4, it's going to be 9 pi over 12. And for pi, it's going to be 12 pi over 12. Alright, if you do this first and change all your denominators, then what you know is that you've got to move to the right 2 pi over 12, or a distance of pi over 6. We're going to add to each of these, and they have a common denominator. It makes it really, really easy. So these are our new values. So we take 0 pi over 12 and add 2 pi over 12. We get 2 pi over 12. We'll reduce them in just a second. We take 3 pi over 12 and add 2 pi over 12. We get 5 pi over 12. 6 plus 2, 8 pi over 12. 9 plus 2, 11 pi over 12. And 12 plus 2, 14 pi over 12. And then we can just reduce our fractions so we have the values for our graph. So we have pi over 2, or 2 pi over 12, which is just pi over 6. 5 pi over 12 just stays. 8 pi over 12 gives me 2 pi over 3. 11 over 12 stays. And 14 over 12 gives me 7 pi over 6. So these are our values, and they're all to the right of the critical values. So we're going to have, let's see if I can fix another color to maybe help us a little bit. Alright, so we have a point to the right of that, a point to the right of that, the one in black, a point to the right of that, a point to the right of that, and a point to the right of that. I'm going to go ahead and label those. This would be pi over 6. I'm going to do it at the top just so we can see it a little bit better. So this is pi over 6. The next key point will be 5 pi over 12. The next key point would be 2 pi over 3. Next key point, 11 pi over 12. And finally, the last point will be 7 pi over 6. Alright, so our beginning point will be here. Our ending point will be here. Sine, you remember, always starts at the axis. This graph has no reflection, so it's going to go up first. And so at our next critical value, we would be at the top of the amplitude. At our next critical value, we back down to the axis. At our next critical value, down to the bottom of the amplitude. And then the last critical value, back at the axis. And this graph looks something like this. Alright, that get a little more complicated. Some of the ones in your worksheets will be a little more complicated, but I know you can do it. You are all awesome Bearcats. Have a great evening.